Hello everyone, let us look at a really advanced topic now, level of detail expressions. Now first understand why we would need to do something like this. So I have the same dataset with me on which we have been working. I want to insert a pivot table. And what I would like to do here is to take my category in the columns, my subcategory in the rows, and the sales in the values. Now here's my question. First, let me remove the decimal places. Now, the question I have is, I would like to know, on an average, in each one of the three categories that we have, furniture, office supplies, and technology, what is the average subcategory value? That means in the furniture category, we only have 4 subcategories. In office supplies, we have 9, and in technology, we have 4. So I would like to find the average of these 4, right? And now if you notice, the answer is like this. So how do you articulate and how do you explain and interpret that number of 1 million? It means that on an average, the sum of each subcategory within the furniture category is doing 1 million. This is not at a transaction level, it is at an aggregate level. So this is at the level of my subcategory. This is similar to finding the ARPU, or the average revenue per user, in the telecom sector. So when we say that Reliance Jio has an ARPU of, let's say, 300, what that means is that I add up every transaction that a customer has made in a year, and then I divide it by the number of months, and then I find the average of the ARPU for all the customers that Reliance has. So this is not being done at a transaction level. So when Reliance says that the average for a month is 320, it doesn't mean that on an average each customer, each transaction is 320. It means that the sum of sales for each customer, if you find the average of that, that is 320. Take some time, wrap your head around it. This is what we are trying to do. We are trying to find the average of all the subcategory totals in each of the categories. So this is the average for furniture, this is the average for office supplies, and this is the average for technology. Let's try to do this in Tableau now. So first, I will select my category. And now we want to do a calculation. So I will say that I would first want to find out for each category what is the grand total, which means I can just put my sales and it tells me furniture is 4 million, office supplies 3.7, technology 4.7. The same numbers that you're getting here as well. What I would like to do now is to do a calculation. So analysis and create calculated field. And here we will say average at the category level. So to do a level of detail expression, I first make some curly brackets. And then we say so we will start by writing include. Now I want to find the sum of sales at the level of the subcategory. So we will say subcategory, and then we put a colon, and then we say the sum of sales. Now before I accept this, let's understand what is happening. It is first creating a list of all the subcategories. We know there are 17 of them. For each of the 17, it is calculating the sum of sales. That means the total of each one of the subcategories. And then we want to find the average. So I can now just put this inside an average, which would be an AVG. And let's look at the result now. So I'm going to keep the average in the table, and now we get 1027, 420, and 1186. So 1.02 million, 420,000, 1.18 million. If you go back to the Excel, 1027, 420, and 1186. See, it's one thing to be able to recreate it by watching the video, but it's very important for you to spend time, really understand how it works, why it works, when to use it, in what use cases will this be applicable. This is a very powerful tool. I have an entire bonus module available where there are over a dozen examples where I explain different ways of using level of detail expressions. But additionally, I would also recommend that all of you read about LOD from the Tableau website. They have explained this in a lot of detail, and I can't do justice to it in a short course like this. I've given you an introduction, told you how important it is, but the three types of LOD, fixed, include, and exclude, are super important, and they really allow you to make these very complex calculations and visualizations.